Hello everyone, welcome. So today, this video is going to be a little bit different. We're going to have a conversation on how to write a game engine from scratch, right? Using the C++ programming language. And look, let me just set the expectations correctly here. I'm not going to teach you how to create a new Unity or a new Unreal. I am mostly interested in talking to you about making a game engine from this kind of learning exercise, right? For you to, if you are a beginner game dev, if you are even an experienced game dev, if you want to really learn how the game sausage is made, if you want to open this black box and understand how game engines are made, this is my goal, right? This is what we're going to talk about. So let's just go and have an honest conversation about how I like to implement the development of a fresh game engine. And while I'm at it, right, let's just do the hard part here. What is a game engine? And I'm sorry, I know I'm going to have to do that. I know that if you are here watching this video, chances are that you know already what a game engine is, and you even try to play around with it, right? Some game engines, you probably installed Unity, you probably installed Godot, you probably installed Unreal, you drag and drop some game objects, you click play, you saw some rendering. So game engines, right, at its core, a game engine is a set of tools, a set of software tools that help us create video games. Right? I know it's a very stupid claim, but this is what they are, right? Let's just get this out of the way. I want everyone to be on the same page. And look, these tools, they can be inside one program like Unity or Unreal, or if you look at game studios, modern game studios, they will have several tools spread across the warehouse, right? So you have several people, animators, level designers, they all will have their special tools, converting files from one place to the other. So you have this Maya scripts, this Blender scripts that animators use and artists use, and then you have this other set of tools that goes and convert things and know how to deploy things to iOS, Android, Swift. You see, it can be one big engine, this kind of IDE, right, this integrated development environment type of things, that can be a game engine, or we can be talking about a set of actual third-party and all over the place tools. That is what game engines are for these big game studios, right? They can be this set of tools that people just kind of combine to create the final project, which is, of course, our game. So this is a game engine, right? It's a set of tools that help us create and maintain and deploy video games. That's it. Right, so let's just talk about something more interesting, right? Besides what a game engine really is, there are different ways that we can interpret what a game engine is. I can be talking about this huge IDE type of thing like Unity or Unreal, right? This general purpose game engines. Or in our case, in this video right here, I want us to simplify our problem a little bit. I'm not talking about this huge monster game engine. I am talking mostly about this code, right? This code base. You're going to have C++ code with header files and libraries and dependencies. Is going to be a project, a code project that is going to help us reason about games and game objects and game properties and animation and rendering. Do you see? It is not going to be an IDE, right? If you are a programmer, you have this big IDE where you have everything in just one big place with an editor, with drag and drop, with mouse, with play, stop buttons, and etc. That is not what I'm going to try to accomplish here. I am talking to you about a game engine, almost like this kind of framework, this boilerplate that is going to help us reason about game objects and game state and game logic. Right, so think about this. Whenever we talk about a game, if you were programming for a very old machine like the Atari 2600, we didn't have the luxury or the machine power to abstract too many things, right? If I was programming the Pac-Man game, I had to think about the bytes that were going to be drawn to draw the Pac-Man bitmap. And if I had a little ball or a little score thing that I have to draw, I had to think about the bytes and the color palette, everything for that particular game. So there was no abstraction. I couldn't think about game objects as this abstract thing that will have movement and physics and artificial intelligence. I was programming, right? Everything was tailored to that game. When I talk about a game engine, it's going to be this code that is going to give us this ability of reasoning about a game as thinking about these high-level ideas of game objects. So I'm going to add a game object. I don't know if it's going to be Pac-Man or Mario or Sonic, right? It's going to be this game object that I'm going to add. I'm going to give some special characteristics so I can have gravity acting on that object. It can collide with other things. Do you see? Abstraction, right? Game engines, they are, at its core, this abstraction machine. And for us to create this abstraction, to enable these ideas of physics, AI, the subcomponents, we can create something from scratch. I think it is very valuable for us to create something from scratch, for us to understand how games are made, right? As I said before, I want us to understand how the game sausage is made. So that opens another question. Gustavo, should we even bother creating a game engine from scratch? Why would we even do that? And that is a great question. I have a blog post about that, right? So who should write a game engine? Should we even bother writing a game engine from scratch? That is a great question. I'm not going to defend saying that everyone should do it. It all depends. We have to be very sober about this. It all depends on what you want to achieve. What are your priorities? Do you want to quickly deploy? Do you want to only see your game running and deploy to several different platforms? Then you might use something that exists already. Unity, Godot, Unreal, or whatever is your preferred game engine. Use something that is already there, something that has been tested. If what you want is to be productive, what you want is to develop and deploy a game, I don't think you should bother that much. But if you want to learn, if you are looking at developing a game engine, and if you are serious about programming games, I think every game dev, every programmer should at least try to create a very basic game engine from scratch. Right? Again, not with the expectation of creating a Unity or Unreal or Godot or whatever. What you're going to create is you're going to have a project, you're going to have a code base that thinks about these ideas of entities, game objects, components, that thinks about artificial intelligence, how to integrate audio, how to render things, how to communicate with the GPU, OpenGL, DirectX, Direct3D, Vulkan. There are several important concepts that I think you should force yourself to implement something like that if you are serious about programming and if your goal is to learn something, right? If you are curious and if you want to learn about game engines, that is what I'm tackling here. So this conversation that we're going to have right now, I'm going to assume that you are in this category, right? You are a programmer, you are someone who is serious about the programming part of games, and you want to learn more about that. Using a game engine and programming a game engine is pretty much just an excuse for us to learn more about very important computer science topics, right? Very fundamental questions of computer science. Because if you look at game development is not kid stuff, right? Game development is pretty much one of the few topics and the few areas that touches almost the entire computer science curriculum. Think about what happens under games and how we program games. You are going to touch so many of this kind of standard computer science curriculum, right? You need to understand what algorithms and data structures you're going to use because you're going to have to use some logic and those things. You need to keep performance in mind, so you need to pick the correct data structures to organize your objects in memory. Mathematics, a huge topic, right? Again, I'm not claiming that you need to be super good at mathematics to be a game developer, but if you're talking about game engines, I don't think you can help but get interested in mathematics, right? You have all these ideas of derivatives, integration, you have linear algebra, discrete mathematics, all these things that are part of the computer science curriculum, you will make use of them whenever you're developing a game engine, right? Computer architecture, you need to keep your eye in the target machine that you're operating, right? So how do you optimize things? How do you squeeze every performance that you can out of the processor that you're using? Computer graphics, well, it goes without saying, right? Almost the core of game engines, rendering, right? Computer graphics, all these algorithms of rasterizing, these transformations in computer graphics. This is a huge topic. This is something that we're going to touch a lot. Compilers and formal languages. I always like to add compilers and formal languages because we need to expose scripting power, we need to interpret some sort of formal language from the user sometimes, from the level designers, we need to parse and interpret those things. Artificial intelligence, right? If you were talking about an NPC or an enemy that needs to go and chase, artificial intelligence is a huge topic, super applicable in game engines and games. Networking, right? Multi-user experiences, these connections that you have to have, networking. UI and UX. So if you want to add power of user interface elements, menus, buttons, events, handling events, game loop. Look, this is just a little snapshot of the computer science curriculum. I guarantee you that if you're going to develop a game engine, you will eventually touch these things. So game dev means serious computer science topics, right? It is serious stuff, it means serious business. Never let people say that game dev is kid stuff. We are talking about high-level computer science questions, right? Very important computer science questions. Everyone is capable of implementing something simple, right? To understand how games and game engines are created. Right. Talking about the size of game engines, right? As I said, that it doesn't have to be this general purpose, huge engines that we have, because we are competing, right? This discussion, we are competing with some big boys, right? We're talking about Unity, we're talking about Unreal, we are talking about CryEngine, we are talking about Godot. These are general purpose game engines. They are super huge. They are extremely professional. They help ship and maintain and debug and develop games all over the world, right? We are competing with some big boys here. That is not exactly what I want to achieve. What I'm talking about here is this kind of more classic idea of what a game engine really is. If you think back in the day, whenever we were programming a game or a game engine, whatever we called the game engine was basically just a couple of routines, a couple of functions that we had in a floppy drive, and we develop a game with it, and then we just have those general purpose functions to, multiply matrices. We have a function to project. This set of files, it was basically just a bunch of C files that we had in a little folder. That was our game engine, right? So that is kind of what I'm looking at here. If you think about these classic examples of things like, think about id Software, for example. id Software was the one creating Wolfenstein 3D, Doom, Quake, and it was this kind of internal, small game engine that helped create one specific type of game, right? So you have things like id Tech 0, id Tech 1, id Tech 2, id Tech 3. They were iterations, they were versions of this internal game engine at id Software, and then as they were improving and evolving the engine, we have id Tech 1, id Tech 2, id Tech 3 for Wolfenstein 3D, Doom, Quake, and etc. You see, very small, they're kind of tailored game engines, very classic type of game engine. If you look at another type of game engine, a Build that was written by Ken Silverman, that was the engine used to create things like Duke Nukem 3D or Blood, a small game engine that you could go create your first-person shooter. You can customize the maps, create the walls, and drag and drop things. That was the Build engine. Another example that I always like to give is if you ever played those LucasArts point-and-click games from the 90s, like Full Throttle, the Monkey Island series, that was using a game engine or a scripting language called Scum, right? Scum, super popular in the LucasArts type of games. An example of a game engine, a scripting language also, that help us create games of a particular style. So this is what we're talking about. It's very simple code that you can kind of just import a couple of header files, you can import some dependencies in your C++ project, and you can just go ahead and start implementing from the ground up these ideas of rendering, these ideas of organizing game objects in memory, right? If you want entities, components, game objects, this is what I'm talking about. Right, that was a lot of preaching, a lot of motivation. Let's talk about the flow that I like to use, right? So let's talk about more technical details. What are the libraries? What are the dependencies that I like to use? How do I go about implementing a game engine? If I have to go and start tackling this right now, what are my recommendations for students, right, if they want to start creating this thing from scratch? And this is it. So how to make a C++ game engine. And I am basically focusing on C++. You will see that I'm saying that one of the first things you have to do is basically choose a programming language. The reason why I'm mentioning C++ is you're going to see people say that it is industry standard, right? Yes, it is. To develop a game engine, they will use C++. But this is not written in stone, right? It's not a requirement that you have to use C++. I like to use C++ because it forces us to think about some low-level details, right? Allocating memory, thinking about how how objects are stored in memory, how do we make the most of our code, right? We have to think about the low-level details. So this is one thing that I like about C++. Whatever type of C++ you want to use, if you want to use really modern techniques, feel free to do so. I personally like to use C++ almost like this C with some extra features, right? I'm a little bit old school, so again, it really doesn't matter. I'm not here to be opinionated about these things. You have to choose a programming language. My suggestion is to choose a programming language that communicates a compiled programming language like C++ that you will compile to a native code to run on the machine. I don't like to have any virtual machine, any layers of abstraction between my code and the processor, right? C++ is a good option for that, right? No middleman. Everything is compiled and runs exactly as native code processor instructions one by one. So that is the first thing, right? Choosing a programming language, that is the first thing that I like doing. C++ is usually my tool of choice. The second thing that I like to point out is, look, we need to be able to create a window in the operating system, right? Even if you're running full screen, there is this idea of a window that you have to create. If you are working on a modern operating system, you need to ask the operating system to open a window because your application needs to work inside that window. You need those permissions of the operating system. Right? Look, and this is super important, right? When I say windowing system and multi-platform hardware access, if you are talking to the hardware of the machine, if you are talking about, if you're running on a Windows machine on an Intel processor, or if you're working with an Apple M1 processor, or if you're working with Linux, the way that we gain access to the hardware, there is this shield protecting the programmer and the hardware, right? It's protecting the hardware from the programmer. I cannot just go crazily and start poking values on memory addresses of that hardware. The shield is the operating system. There is an operating system protecting that hardware. So for me to go and be able to display and paint a pixel on the screen, for me to go and read values from the keyboard and events from the keyboard, right? Access these hardware elements, access the mouse coordinates, emit sound. Hardware access, we need to ask permission of the operating system. There are two ways that you can go about this. You can write native code. So if you're working with Windows on Intel, you can have a version of your code that asks the Windows API to go and display something and paint a certain pixel with a certain color, or you use what I like to use, which are these multi-platform libraries. If you ever heard of things like SDL, GLFW, SFML, they are general multi-platform libraries that will help us gain access to the hardware, regardless of the platform, regardless of the operating system that you're using. Which means, in other words, if you use SDL, if you use SFML, and if you use GLFW, for example, these libraries, they are multi-platform, meaning that you're going to write one single C++ code, and these libraries are smart enough to communicate with the operating system specific details to get the correct hardware permissions for you. And then you can use SDL to just say, SDL, create a window. And then SDL creates a window, regardless if you are running on a Mac, a Windows, a Linux, a BSD, a Raspberry Pi, it doesn't matter, right? So that is the beauty of using these libraries. SDL is usually my library of choice when it comes to windowing system, multi-platform windowing system, right? As a teacher, I like multi-platform because I don't have to worry too much about what is the operating system or the processor that my students are using. If they are using Windows, Raspberry Pi, if they want to run something on a OpenBSD unorthodox laptop, it's going to work anyway, right? So this is one of the main things that I want you to take from this. We need to use some sort of library to communicate with the operating system, and I like to use a multi-platform library like SDL, right? I like to use SDL in most of my courses. Good stuff? Right, so now we have these ideas of C++ being our core programming language. We have a windowing system and a way of communicating with these kind of subcomponents of the hardware, right, using SDL, let's say. One thing that is super fundamental in developing games, you will see people call the game loop. Look, I like to spend a lot of time explaining and really dissecting these ideas of game loop. It is not as simple as writing a while true forever. We need to find a way of controlling the game loop and tie these things to these ideas of time, right? So how many times per second, how many frames per second are we going to render our animations? How many times per second are we calling the update of the physics ticks of our simulation, right? This has everything to do with the game loop and how we implement a game loop. I am going to link in the description a very good article that talks about game loop and shows some implementation options, right? So how you could go and tackle the game loop on your game engine, okay? So this is a super, super important topic, the game loop. And together with the game loop, one of the things that we have to do in our game loop, frame per frame, step by step, is these ideas of getting the input from the gamepad, getting the input from the mouse, getting the input from whatever, right, the keyboard. So input and event handling. This is kind of inside our game loop, right? We're going to iterate, loop, and input those events from the keyboard, from the gamepad all the time. So this is also something that for us to get input and handle events, do you agree that we're going to have to go and access hardware elements, right? Keyboard, gamepad, mouse. That means communicating and asking for the operating system for that permission to access hardware. So this is something that SDL and some other libraries like SFML, even DirectX, they help us achieve. They help us communicate with these hardware elements. The same way that we have the windowing system, input and event handling, we can use SDL, for example, right? All you have to do with SDL is saying SDL get event, and then if the event is key down, and if the key down is space bar, then I do something, right? Then I can shoot a missile in my game. It's as simple as calling an SDL function to process and check if that event is what you want. So input and event handling is usually the next thing that I do whenever I'm creating a game engine. And then we arrive at this topic right here, representing game objects in memory. Look, this is probably the most important thing that I think students should focus whenever they are talking about creating a game engine. How are the game objects of our game going to be abstracted, and how are we going to think about these things in terms of memory? How are they going to be allocated in memory? How are we going to represent these things? Are we going to use classes and objects? Are we going to use design patterns of having entities, components, systems? There are different design patterns that people use to represent their game objects in memory. This is a huge topic. This is something that in my courses, we explore, we implement from scratch. I like to use this as an opportunity for us to learn a lot about data structures, because you're going to have to use data structures in memory to hold those entities, to hold those game objects, right? You have to hold those things, represent and store those things in memory. Are we going to use arrays? Are we going to use a tree structure? Are we going to use this list of, this collection of objects, this pool of objects? There are several different techniques, algorithms, different ways for us to represent game objects in memory. This is usually where you will see people talk about something called ECS, right? This entity component system, that is a buzzword whenever people are talking about game engines and game development. ECS, they gain a lot of popularity. They are very popular whenever we try to organize these game objects in memory, ECS. Which also brings me to this consideration, which is, what do you want to do? Do you want to really dive in and go down this rabbit hole of learning how game objects are stored in memory and implementing things from scratch yourself manually? Or do you want to use a library that helps you already do that, right? You don't have to create these things from scratch. And you will see that several game engines, they actually use a third-party library to control this ECS, to control these objects in memory for us. So there are some ECS libraries that I like to use if I feel inclined to just use something that is already done and has been tested and it is a professional third-party library. There is something called Entity, right? ENTT. Another library that I like using, especially in C projects, is something called Flex. So both Entity and Flex, they are ECS libraries, right? They are Entity Component System libraries, and they will help us abstract these ideas of creating entities, creating components, and etc. What do I mean by entities and components? Look, if you think about how most game engines are structured, they will have some sort of entity component type of design pattern behind the scenes. What are entities and what are components? Well, an entity for a game engine is pretty much this game object, right? If you ever work with Unity, an entity would be what Unity calls a game object. It's a thing that you can add to your scene, like the main player, like an enemy, like a door, like an obstacle. So these are the entities, right? The actors of your game. And components are going to be this data that you can add, these characteristics and data that the entities can attach. You can just go and plug to your entities. So you might have for your entity main player, right? If you have a main player, you can add components for velocity, position, physics, AI, script. You can have a sprite that is going to be used to render, right? A PNG image, which is a sprite. So these are the components that you can plug to your entities. And if you have, let's say, another entity, your enemy, that enemy will have different components that are going to be plugged underneath it. So you can have, again, velocity, position, you have physics, you have the idea of collision, right? So you have to be able to collide with that enemy. You have these ideas of health. So what is the current health level of the enemy? These are all components that we usually go and plug on those entities. And you will see that this is one of the preferred ways that game engines like to think about organizing game objects in memory, right? So you can go both ways. If you really are serious about programming and you want to implement this ECS thing by yourself, right? If you want to code, it's a good option. You will learn a lot along the way. You will suffer a little bit, but you will learn a lot. Or you can just go this kind of easier way, which is include entity.h or include flex, and then you let flex manage those objects and manage those entities and components and systems under the hood for you. Right? You can basically just delegate this whole thing to an ECS library. That is also an option, and that's perfectly fine. Right, the next thing that I want to discuss is the idea of rendering. This is at the core of our game engine, and it has to do with the nature of the games that we want to develop. Right? So your game engine, are we talking about 2D or are we talking about 3D rendering? And the answer to that question is going to change the way that we structure and code the rendering capabilities of our game engine. This is, again, a monster topic. It's a great opportunity for us to learn how things are implemented under the hood. You need to probably take advantage of hardware acceleration, meaning GPU access, right? So you want to have GPU execute things in parallel for you. So you want to communicate with the GPU, you want to send this data, you need to have these ideas of sprites, PNG images, bitmaps, these graphical patterns that every game object is going to work with. And even more, right? Not just a simple PNG image. You are probably going to have to control animation, so you're going to be able to animate those sprites as time passes. And my personal recommendation for my C++ projects is, if you are working with 2D game engines, I would also take advantage of SDL. Do you see? SDL is a big helper whenever I'm developing graphics applications and this type of 2D game engine, right? 2D games, SDL is a super huge help. If you're talking about 3D games, right? If you want to create these ideas of 3D objects, that will require us to work a lot with the GPU. We need to use the GPU, we need to use graphics acceleration to render those things. So we need to send vertices, we need to send texture information of the objects, we need to send all this vertex information to the GPU to be rendered by our GPU, right? And for that, whenever we talk about game engines, one of the big responsibilities of a game engine is to abstract not only software, right? Abstract how we think about software components and software game objects and etc., but also abstract hardware. Most game engines, they will use some abstraction for the GPU. Things like Vulkan, things like Direct 3D or OpenGL, they are very popular examples of this software abstraction for how the GPU works, right? For how the GPU hardware works. So we're going to have Vulkan, OpenGL, or DirectX, or whatever. That is going to be the graphics API that we're going to use to communicate and send instructions and send data to the GPU. So the way that we communicate with the GPU is through this graphics API. You have to make a choice. What are you going to use? Do you want to use OpenGL, right? So then you have to use the OpenGL API and ask for those OpenGL functions, right, to invoke those functions. Or if you're using specific Microsoft products, if you're working with Xbox or if you're working with Windows, then you can use Direct 3D or Vulkan, right? Vulkan is also a very popular option. Graphics API. If you are talking about rendering things in 3D, you will probably take advantage of what we call a graphics API. So the graphics API is how we're going to send the data, right? The vertices, the texture, the normals of the vertices, this huge information of the 3D model, we go and we implement to be rendered. And just before I move away from rendering, it's also a good idea to think about loading 3D files. So how do we load information that comes from Blender? Right? You're going to have a file that an artist is going to go and model in Blender, and they're going to export from Blender. So it would be a great idea for us to be able to import those format files that we have, right? So what is the file format that 3D object is coming? Is it an OBJ file? Is it a Collada file? Is it an FBX type of file? Is it a .blender file? I think your game engine should be able to load this format, right? This 3D file format that the artist is exporting. My recommendation, again, right? What would I suggest? I always suggest students to start with a simple OBJ file. I think it is one of the simplest options out there. Every game engine uses, I think every 3D modeling software knows how to export an OBJ file. And this is rendering, right? Of course, there's a lot underneath this topic right here, rendering. This is just me saying, oh, yeah, you have to tackle rendering with your engine. But there is a lot that you have to learn, and if you want to look at my recommendations, I have a couple of links in the description as well. Right, next thing that after you have windowing system, after you have this ECS working, after you have these ideas of input, game loop, everything working correctly, I would probably try to implement some sort of physics, right? I think it is a good idea for us to have these ideas of at least gravity, friction, drag, but also collision detection and collision resolution, right? We need to detect if two bodies are overlapping and if they're colliding, but also how do we resolve that collision, right? Do we apply impulses to resolve and send them one way and the other way? Or do we just basically go and separate them so they're not colliding anymore? We have to think about these physics ideas. Again, that whole dichotomy also exists here. Do you want to implement things by yourself and really think about the mathematics that go under collision detection? If you want to talk about this collision resolution, physics formulas, you can just spend your whole life thinking about physics and implementing all this cool stuff. Or you can just say, include this physics engine library, right? This Box 2D or Chipmunk 2D, or if you're talking about 3D, you have a Bullet Physics. You have these third-party physics engine libraries that you can just basically plug, include, and start using in your code. The whole pros and cons also apply here, right? What do you want? Do you want to write things from scratch and have more control, this tailored control over how the physics is going to work in your game? Maybe you have this very weird physics that you want to implement, then you can just code yourself. But if you're just talking about vanilla gravity, vanilla forces being applied, vanilla collision detection and resolution, why not just use something like Box2D, right? I like to use Box2D in my projects if I'm talking just about this vanilla physics implementation. Right? So again, those two options. Code it yourself, which is super cool when you're going to learn a lot, or you can just include Box2D or include Bullet and just say, Bullet, handle the physics for me. Right? Handle these rigid bodies for me. I don't want to worry about anything. Just get me the result back and do all the hard math behind the scenes. So that's physics, right? Those are kind of my suggested libraries that I like to use in my projects. Right, user interface. Look, weirdly enough, this is not something that students think is going to be hard to implement, right? UI, they think, oh, I just have to render a button, click the button, something happens. Look, UI is very hard, all right? Very easily, your code is going to gain a lot of complexity because you have to render different types of elements like sliders, buttons, drag and drop abilities. You have to move, create windows, panels. And even more importantly, and even harder, you have to keep track of the state of those interactions. Is the button clicked? Is the button pressed? Am I hovering? What happens? You see, you have to keep track of a lot of the state control by adding UI elements. When I'm saying UI here, I'm talking about game engine UI tools, right? I'm not talking about the UI that you display to the gamer, right? You're not talking about menus for the game or dialogues for the game. I'm talking about creating UI elements for your game engine, right? These tools inside your game engine. So if you're going to have a panel and a button that adds an entity, a button that changes the velocity component of your objects. These are the UI elements that I'm talking about. Luckily for us, there are super smart libraries that help us add UI control to our game engines. And if you do not live under a rock for the past 10 years, there is something called ImGui. And Dear ImGui is one of my favorite libraries when it comes to embedding UI abilities to our game engine. ImGui is super fast. It communicates super well with hardware acceleration. So ImGui works really well with the GPU. It just goes and sends information to be rendered by the GPU. We can easily just say, add panel, add button. If button is pressed, this happens. So it is super useful for us. And even more importantly, ImGui, right? This library ImGui that I'm suggesting, it is agnostic to the rendering that you are using. So if you are using Vulkan, you can have ImGui work with Vulkan. All you have to do is connect ImGui to Vulkan. If you are using OpenGL, all you have to do is connect ImGui with OpenGL. So this is the beauty of ImGui as well. So let's just cut the story short. If you want to add UI options inside your game engine, I would suggest go with something like ImGui. And I just want to also make something super clear. Game engines, they don't necessarily need to have UI. You don't need to have these fancy UI elements and panels and buttons. A game engine can be just the code that has all this framework and API for us to add objects, remove objects, add components, remove components, change animation speed. It can be all done via code. And that is absolutely a proper game engine. So a game engine doesn't necessarily need to be this IDE-like application with all these panels and buttons and things that you drag and drop. right? Of course, since game engines are things that we use to increase the performance whenever we're developing a game, it makes sense for us to have an UI to get this input, right? This user interface and improve the user experience of whoever is using the game engine. But they don't need to have a UI, right? A game engine doesn't necessarily need to have a UI. It's good if they do, but they don't have to. Before we kind of stop, I think we are starting to really grow in complexity, right? If you go and your game engine has UI, physics, rendering, ECS, if you have all these things so far, I would bet that your code is growing in complexity. But just before we say goodbye, I just want to say that scripting is something that I like to expose in my game engines. This is something that I probably will tackle next. If you have a team of programmers developing a game, not everyone needs to be a proficient or a professional C++ programmer. And even more importantly, you don't want to expose memory control and memory allocation, and you don't want them to worry about this memory management type of things, right? These hard tasks. So what we usually do is we add and we embed a scripting language, something that is a lot simpler, something that is a lot more minimal. For example, Lua, Python, even JavaScript, I have seen people expose, even C#, right? If you think about scripting languages that are easy, that they don't have to worry about memory management, they don't have to be professional C++ programmers. So we are not going to let them code in the native language of our core application. We're just going to go and expose a scripting language. Lua is probably my favorite scripting language to embed with my C and C++ projects. You will see that it is super fast, it gets the job done, so you can just add to your C++ project and compile with your project. All you have to do is include the Lua libraries in your project, and pretty much you're ready to go. You can just go and start exposing the Lua language to whoever needs to script things. And whenever I say scripting, you can basically delegate the whole logic of what happens when an enemy collides with a bullet. That can be delegated to a Lua script, right? So in the Lua script, you have the logic of what happens whenever those two things collide. What happens when my player exceeds 100 velocity? You can have a Lua script as well. If you're thinking about AI, artificial intelligence logic, and artificial intelligence algorithms, you can code all of those algorithms and the behavior of an enemy, how they pursue, how they chase the player. That can be all delegated to a script, right? So whoever is scripting the level, they will be able to go and dictate via a Lua script what happens to the enemy, what happens to the bullet, what happens to the player via a script, right? Something that you expose as a Lua script. Whew, lots of things. I'm going to stop right here, right? Look, let's be honest. If you implemented windowing system game loop, if you have a robust game loop, frames per second, if you have these ideas of rendering, if you have animation, right, frames going back and forth, if you are rendering things correctly, if you have these ideas of input from the user, handling keyboard, mouse, joystick, pad, and etc., if you are rendering things correctly with the GPU, sending vertex 3D file information to be rendered on the GPU, if you have some sort of physics engine already embedded and you have gravity, friction, drag, forces, if you have some sort of UI, scripting, audio, and if you have all these things working, let me be honest with you, this is a huge accomplishment, right? Game engines, they are not an easy task. This is kind of my 2 cents. This is how my roadmap of how I like to think about the development of a game engine using C++. Right? If I have to suggest my students, this is usually the flow that I follow. But let's just always keep in mind that game engines, they are a lifelong exercise, right? We are always learning about this, how these things are implemented. Every day I have to go and keep myself updated with research and keep myself updated with new techniques that people have been implementing. When it comes to rendering, physics engine, UI, there are always new libraries, there are always fancier ways of doing things. So don't think that you're going to develop a game engine and then, yeah, goodbye. If you are serious about becoming an engine programmer, this is a lifelong journey. It's a lifelong pleasure that you're going to be able to go and savor. You will never stop learning about game engines if you go down this rabbit hole, which is a good thing. In my experience, that is something that is good. You will never get bored. But again, I just want to conclude this conversation, this whole preaching thing, right? I told you, this was going to be more of a conversation and recommendation type of thing. My recommendation is, think very well, if you really want to implement this, what do you want to get out of creating a game engine with C++? What are your motivations? What are your expectations? Do you want to create a new Unity and make money and be more productive? Don't do it. That is not the way to go, right? But if you want to start small, if you want to, savor every line of code and really think about, really grow as a programmer, thinking about the data structure that you're going to pick to organize your game objects in memory. If you want to think about this level of detail, if you want to really grow as a programmer, right, as a low-level programmer, I think there's a lot to gain from attempting to create a game engine for yourself. Go ahead, think about the game loop, think about physics simulation, think about rendering, and this is going to help you a lot when it comes to exposing your work and proving your work to other people. Right? So if you're going to an interview, if you're going to show to employers, if you're going to show to people, if you have a GitHub repository with your engine, that is the proof that you know what you're talking about. That is always good when it comes to employability as well. Very well. If you are looking for resources online or books to learn more about game engine development, I have a couple of suggestions. The first one, I think you probably know what I'm going to say, is the Bob Nystrom book. That is a staple. It is a great read. It's a very storytelling type of thing, where he goes and explains some of the challenges with game programming, and while presenting some of the design patterns that we can use, and that overlaps with these ideas of game engines, right? So Bob Nystrom, Game Programming Patterns, that is an excellent book. That would be one of my recommendations. If you want something more hands-on, and I know that I'm biased, but I think it is a great resource to start, is my course, Create a Game Engine, a 2D game engine using C++. I developed this course to be this kind of introduction to game engines. We cover a lot of ground. So basically everything that you saw me explain right here, right? Rendering, game loop, ECS, we go and we code from scratch. We code together a game engine, thinking about all these fundamental building blocks that go right behind the hood of what games really are, right? Again, I know that I'm biased, but I think this is an excellent resource. Create a game engine using C++, SDL, and Lua, right? I use also Lua. I embed Lua in our game engine. I think it is a good starting point. Something else that I really like is Casey Muratori's Handmade Hero project. It is a little bit overwhelming. It is a long project, but it is super in-depth. And if you are serious about programming, I would recommend you to go and check the whole Handmade Hero, the whole ethos of Handmade Hero, of actually creating things from scratch and thinking about the low-level programming, summarizes why I think it is important for us to implement a game engine from scratch right there. And if you do like this type of content, right, this low-level understanding of how things work, make sure to subscribe and sign up to our newsletter. I will always try to release more courses and explain a little bit more how the game sausage is made. See you soon.